Okay, 4.6. Okay, remember that whole conversation on Friday? Or Thursday? Wednesday? Okay, here we go. We're starting. Alright, 4.6 complex numbers. So we're going to talk about things like what is the square root of negative 24? Have you ever taken the square root of negative anything? Usually we say you can't and we move on and we're happy with that. But that's not actually the truth. We can talk about the square root of negative numbers. So we're going to start talking about I, which is equal to the square root of negative 1. I is an imaginary unit. Okay, we're not talking about imaginary in the sense of it's either real or it's imaginary, like your imaginary friend doesn't actually exist, right? It's not saying that it doesn't actually exist, it's just called an imaginary unit. So it's just a label, like Kara is called Kara, that's her label. It doesn't really mean anything about Kara, right? That's just her label, right? Right. Same thing. So the fact that it's called imaginary is just this label. Doesn't mean that it's actually not real. Does that make sense? It's not a real number as far as the real number system. It is a real thing. And it's kind of difficult to talk about. Okay, so if I is the square root of negative 1, what would I squared be? Negative 1. Because we would have the square root of negative 1 times the square root of negative 1, which would be negative 1. Usually when we have, in the past we have like square root 2 times square root 2, that was equal to square root 4, which was 2. It was always equal to whatever was inside that square root. Do you remember that? Yeah. So since we're multiplying it by itself, it's going to be equal to whatever's inside the square root, which was negative 1. This is really weird, right? We've never actually squared anything and got a negative number until today. Like your whole life. You've never squared anything and got a negative 1. Or negative anything. And here we are. It's happening today. Today's a new day. It's exciting, isn't it? Okay, so for example, if we have the square root of negative 3, we could write this as the square root of negative 1 times the square root of 3. What is the square root of negative 1? Okay, let's back up for a second. Why can I do this? Why can I take the square root of negative 3 and write it as the square root of negative 1 times the square root of 3? Why? It starts with a P. Ends with properties. Properties, yes. Y'all are really smart. Okay, properties. Y'all are laughing at the fact that I said you're really smart. Don't laugh at yourself. Okay, so we have the square root of negative 1, and what is the square root of negative 1?
Negative 1. Square root of negative 1 is
Y'all are going to be annoying the people watching this video. Sorry if you have to rewatch this. Okay, so we get the square root of 3i. I always usually write the i's at the end. You don't necessarily have to do that. You can write them at the beginning. It's just a habit thing. So we have the square root of 3 times I. But we have to pull that I out. Okay? So let's do a solving problem. So let's say we're going to solve 2x squared plus 18 equals negative 72. Okay, we have a thing squared. So how are we going to solve this? Okay, I don't want to know the specifics. I mean, like, by what method are we going to solve this? If we have an x squared term and no other x terms. Solve by square roots. Okay, when we're solving by square roots, we're going to get the thing squared by itself. So I'm going to subtract 18. We get 2x squared equals, what is that? Negative 90. Then we're going to divide by 2. So x squared is negative 45. Then we're going to take the square root of both sides. Okay. When we take the square root, we get x on the left. What happens on the right? What goes right here? No.
Negative 1.
Yes, plus or minus. Okay, we also know, like you all said, since this is the square root of something negative, we're going to pull out an I, right? So I have plus or minus I times the square root of 45. Can we reduce the square root of 45? If we draw a factor tree, what are the factors of 45? 9 and 5. So right there we have square root 9. What is the square root of 9? So this is going to be plus or minus, okay, 3. And then what's still in the square root? 5. And we have the I left. 3 root 5. Or you could write this plus or minus 3I root 5. However you want to write it. That's it. So the only thing is now, when we have these complex numbers, when we have these imaginary numbers, you have to take out the I. You still have to reduce the radical the same. You still have to solve the same. Just if you have square root of negative, we have something to do with it now. Got it? Sure.
Wait, what?
It's okay. You don't need to know what she said to understand. Okay, let's see. Complex numbers. Complex numbers are different than real numbers. Real numbers, we would just write the number, right? Like 15, that's a real number. For complex numbers, we have a plus bi. The a and the b are both real numbers. I know it's going off the screen. I'll fix it. I is the imaginary part. Okay, a plus bi. So we could have something like 2 plus 3i. That's a number in the complex number system. So really different than what you're used to, right? Usually if I want you to know a number, I just tell it to you, right? I don't say that 15 is 13 plus 2. I guess I could, but usually you just say 15, right? I learned complicated. That's why they're complex. A while ago, I think. No. Okay, adding. Okay, adding. Here we go. If we're going to add two complex numbers, it would look like this. A plus bi, c plus di, and we're going to add them. We're going to add the real parts and then add the imaginary parts.
What is C and D then? Is that like in the places A and B?
Yeah, this is like two different numbers. Okay, so if we were going to add these, we would get A plus C. Those are going to be the two real parts that we add together. And then we're going to add the imaginary part, so B plus DI. So example. Sometimes. Okay, so 9 minus I plus negative 6 plus 7I. So, okay. Okay. So you can add the number parts, the regular number parts. So 9 minus 6 is 3. And then you could add the imaginary part. So negative I plus 7I is 6I. That's not bad, right? Okay, subtract. So we're going to subtract the pieces just like we added the pieces. So we would have A minus C plus B minus DI. Just like usual with subtracting, make sure that you distribute that negative sign. Okay, Rich, what are you working on? Okay, bring them to me. Bring them to me. Bring them to me, and you can talk to me about it after class. I've tried. I'll try some more, but here. Okay. So for subtracting, we have 8 minus I minus 5 plus 4I. Okay? So we have 8 minus 5 is 3, and negative I minus 4I.
Is that a plus I or is 3?
This is a plus. So negative I minus 4I is negative 5I. Again, the most important thing to remember is that you distribute that negative sign. Okay, well that's what we're doing. We're taking the negative I minus 4I and it's becoming negative 5I. This one? Yes. Yes. How about we just do a couple more examples? Okay. Alright, example. Let's do 15 minus 9I minus 24 minus 9I. Okay, we have 15 minus 24 is negative 9. And negative 9I minus negative 9I is 0I. So just negative 9. You don't have to write the 0.
Wait, wouldn't that
Yeah, right. It would turn into negative 9I plus 9I.
Oh, okay.
Okay, let's try another one. Let's do 9 minus I plus negative 6. Oh, wait, just do that one. Just kidding. Let's do Let's do 3 plus 7i plus 8 minus 2i. What is 3 plus 8? 11. What is 7i minus 2i? Negative 5i. 7. Oh, no, it's not. Just kidding. Okay, here's what I want you to do. I'm going to stop this for a second. I want you to work